In this video I'll show you how the problem of empirical underidentification can arise in structural equation modeling SEM or confirmatory factor analysis CFA. If you're working with SEM or CFA, you probably know that you need to have an identified model. That is a model where there's enough information to estimate the parameters. Primarily, this is a theoretical question, so you deal with the identification issue before you start acquiring your data, but there is an empirical side to that too. It's possible that in theory your model is identified, but with your specific data points, it's not identified. This is called empirical underidentification. I will show you 4 different situations where this can arise. The first one, we have 2 correlated factors with 2 items each. As you maybe know, for an isolated measurement model, you need at least 3 items for a factor to be identified. If you have 2 correlated factors, then 2 items for each factor, that's enough. So you can estimate this model. This model is actually over-identified, but only as long as the 2 factors are really correlated. Because if empirically you specified a model where in the end those 2 factors are not correlated, contrary to your expectation, then this model breaks down to 2 isolated factors with 2 items each, and an isolated factor with 2 items is not identified. So without the correlation between the 2 factors, you won't be able to estimate this model. The second possible situation for empirical underidentification, you have a factor with 3 items, which is, for an isolated factor, the minimum you need. But now 2 of those 3 items are extremely highly correlated. So we have the case of so-called collinearity. In practice, this can result from 2 items which are almost identically phrased. Because if this happens, then you have only 2 pieces of empirical information, the item 1 and the combination of item 2 and item 3. And you can't estimate a factor with only 2 information sources. You need 3. But empirically in this case, you only have 2 separate information sources for the factor, and that's not enough. The third problem, again, a measurement model with 3 items. Now one of those items, because of some misspecification, doesn't really belong there. It has no relationship to the other 2 items and therefore no relationship to a common factor. So even though in theory you had 3 items, which would have been enough, in practice you have only 2 items for this factor, and 2 items for a factor is not enough. What these 3 possible situations had in common, the number of items was at the bare minimum. And if you do that, then you run the risk, if those items don't behave as they should, that empirically the model doesn't work. So most cases of empirical underidentification can be solved if you use at least 4 items for each factor. But of course you have to decide that before you start acquiring your data. The fourth possible situation for empirical underidentification, here we have a factor with 5 items, so the number of items is no problem. And as usual, we set the loading for the first item to 1 in order to assign a metric to the factor. If, however, this first item doesn't really belong there because of some misspecification, then it's not possible to assign a metric to the factor. We have enough empirical information for the factor in itself. We have 4 items left that are related to the factor. But we don't know how to assign a metric because this metric with a loading of 1 is used for an item that has no relationship to the factor. So this estimation will break down too. In contrast to the other 3 cases, you can rectify the situation even after acquiring your data. You just have to change the way how you assign the metric to a factor. You could set one of the other 4 loadings to 1 instead of the first loading, or you can set the factor variance to 1. And then this model could be estimated without problems. Those were 4 main possibilities how empirical underidentification could arise in a CFA or an SEM. Key takeaway: most empirical underidentification situations can only result if you use the bare minimum of indicator variables or items for each factor or each latent variable. As soon as you use 4 or 5 items for each factor, the risk of empirical underidentification goes way down. Thanks for watching and see you in the next video.